All right, so we continue with Ethereum. Ethereum was introduced in July 2015. So it is like 6 years later than Bitcoin, but currently it is very famous. Ethereum is the technology powering the cryptocurrency Ether, shortened as ETH, and actually the university ETH Zurich is a little bit angry due to that. They have to send a lot of tweets saying that they're actually a university, not a cryptocurrency. But it is shortened as ETH, and it supports thousands of decentralized applications. These are now called dApps. Probably you heard the term. So currently, this is why we have a hype of Web3 and Metaverse and so on. So initially, Litecoin was the second biggest cryptocurrency, but since January 2018, Ethereum is the second largest cryptocurrency in terms of market capitalization, behind Bitcoin. So this is why you hear Ethereum a lot these days. So actually, people refer to Bitcoin as digital gold, and for Ethereum, they refer to it as digital silver. Okay. So Ethereum blockchain is a distributed public ledger where transactions are mined into blocks by miners who solve cryptographic proof of work challenges. So this is important. I included this sentence because since the day one, since its introduction in 2015, Ethereum designers were not happy with proof of work because people are complaining that it consumes a lot of electricity. So they said that they will try to move on to transition to proof of stake. So this is why everybody thinks that Ethereum is a proof of stake algorithm, but it is not. It consumes a lot of electricity by miners, but maybe this will change soon, and I will talk about it in a few minutes. In this ecosystem, an account is an entity represented by an address that is capable of submitting transactions, as we have already seen in the Bitcoin. But in Ethereum, there are actually two types of accounts. One is externally owned accounts, which are controlled by anyone holding the corresponding private key. So this is the thing that we had in the traditional Bitcoin accounts. But secondly, we have contract accounts, which contain executable pieces of code called smart contracts. So this is where actually Ethereum is more famous these days, because people are writing smart contracts. Even those people who don't know anything about blockchains, cryptocurrencies, they watch a video or tutorial about smart contracts and they know how to write a smart contract, but they don't know how it is done actually on the blockchain. So a smart contract is a program run by the Ethereum Virtual Machine, which leverages the blockchain to store its persistent state. Okay, since a lot of alternative currencies copied Bitcoin code, some of them also copied Ethereum code, so they also support Ethereum virtual machines. So a smart contract you write for Ethereum actually also works on other cryptocurrency that also supports Ethereum virtual machine. A transaction is the transfer of funds between accounts or an invocation of a contract's public method. Okay, so let's talk about Ethereum Classic. This is an important hard fork. In 2016, a decentralized autonomous organization called the DAO, a set of smart contracts developed on the platform, raised a record $150 million in a crowd sale to fund the project. But there was a problem with their smart contracts. So the DAO was exploited in June 2016, when $50 million of these tokens were stolen by an unknown hacker. So you know that since they stole it, you cannot modify anything on the blockchain. We talk about this. Once you write something, it is written there. So once somebody stole it, it is stolen. So there's no central authority that we can call and take it back. But since Ethereum is organized by Ethereum organization, they say that maybe we can create a hard fork here and take this back. So the event sparked a debate in crypto community about whether Ethereum should perform a contentious hard fork to reappropriate the affected funds. This resulted in the network splitting into two blockchains, Ethereum with the theft reversed and Ethereum Classic which continued on the original chain. Okay, so this is why we have two different currencies right now. A hard fork, such an hard fork creates, two different cryptocurrencies. After the hard fork, Ethereum subsequently forked twice in the fourth quarter of 2016 to deal with other attacks. So I'm talking about this because maybe sometimes you need a central authority, because this cannot happen in Bitcoin because we don't have an authority there. Okay, Bitcoin developers cannot say that let's have a hard fork because people would not listen to them. But here, Ethereum organization actually said that let's make a hard fork, and people followed the original. People followed Ethereum, the hard fork, and this is why Ethereum actually more. The price is higher than Ethereum Classic right now. I wanted to talk about this hard fork because another hard fork may happen when they choose to move on to proof of stake. Okay, so let's look at Ethereum mining. So in the last 7 years, I think there were like 10 different upgrades, and these upgrades are actually hard forks. Okay, Ethereum actually provides these hard forks. Probably there's a list of them, maybe in the Wikipedia. And in the Byzantium hard fork, which happened in the late 2017, the initial reward of 5 Ethereum was reduced to 3 Ethereum, with this hard fork. Okay, so I told you that there is no limit in Ethereum, the total amount limit. And before this upgrade, the mining reward was 5 Ethereum. So people realize that there are a lot of Ethereum circulating around. So this is why at the upgrade, they reduced this reward. Of course, this is why you have to follow all of these upgrades, because this also affects the prices, right? And after the Constantinople hard fork, which happened at 28 February 2019, miners received 2 Ethereum. It is from 3 Ethereum. Okay, this is the current reward. But we mentioned orphan blocks, right, in the Bitcoin. Whenever 2 miners solve the problem approximately at the same time, we have a conflict, but one of them will be longer and we will follow that. So the other one will be orphaned, and that miner will not receive any rewards, right? In Ethereum, we call them uncle rewards, and uncle blocks, and uncle blocks are also rewarded. So even if you have one or more consecutive blocks that are orphaned, they are called uncle rewards. And if you include them in the original blockchain, and there's an inclusion incentive for the miners, so the miners who found the uncle reward will also receive some Ethereum, but also the person including them in the current block also receives some Ethereum. So the mining reward is not as fixed as the Bitcoin, as you can see, because if there are more uncle blocks, there will be more Ethereum in circulation. Okay, and I told you that block addition time is 12 seconds, but another upgrade actually modified Ethereum in the following way. Since the London upgrade on 5th August 2021, transaction fees are not rewarded to miners. They are simply burned. So since this date, all of the gas fees people paid when performing Ethereum transactions are actually removed from the system. So this kind of strange approach to remove the amount of Ethereum that is in circulation. Okay, but not much people knows this, but this is since August 2021. This is what is happening. Okay, so let's look briefly about Ethereum mining algorithm. So Ethereum's mining algorithm is called ET hash. Is a modified version of the Dagger-Hashimoto algorithm. It uses SHA-3. Actually, a little bit modified SHA-3 because the padding is different than the one that is included in the NIST documentation. This is why they prefer to call it Keccak instead of SHA-3. But this is ETH is a memory hard algorithm and was thought that it would make the algorithm ASIC resistant. But there are ASIC that can do ETH mining and these devices are in the market for years. Some of them are not functioning right now. It will be clear in a few minutes why this is the case. But ETH is based on choosing subset of a fixed resource called DAG, which is short for directed acyclic graph, which is updated every 30,000 blocks, which is amounts approximately 5 days. So there exists a seed which can be computed for each block. From that seed, a 16 megabyte of pseudo-random cache is computed. And from this cache, actually you generate a 1 gigabyte data set that we call DAG. And so as you can see, this is where the memory hardness comes. The device has to have at least 1 gigabyte of memory. But the thing is that this data set increases in time. So mining involves grabbing random slices of the data set from this huge data set and hashing them together. Verification can be done with low memory by using the cache. So this is why verification is fast. Even though the algorithm is memory intensive, the verification does not require you to use DAG, but it requires you to use cache, which is very small. So this is why the verification is fast. So this is why they have such an approach. So currently, I just looked at the last night. The DAG size increases linearly over time, and currently it is 4.96 gigabytes. Okay, as you can see, it started with 1 gigabyte, but the new blocks are added. This data set increases linearly. So as you can see, this can cause some problems. I will talk them in the following slides. So many GPUs and ASICs stopped mining Ethereum after DAG size exceeded 4 gigabytes because, some GPUs have 4 gigabytes of global memory, and some ASICs also had around 4 gigabytes of memory. So when this exceeded 4 gigabytes, which is currently 5 gigabytes, these devices stopped mining Ethereum. For GPUs, you can go and mine something else, right? And for these ASICs, they actually try to mine something different, but that algorithm has to be ETH again. So you need another cryptocurrency which uses the ETH mining algorithm so that your ASIC also can mine that, because ASIC is a dedicated hardware. It cannot do anything else. Okay. So here, many GPUs will no longer mine Ethereum once DAG size exceeds 6 or 8 gigabytes, right? Because there are some GPUs with 6 gigabytes, and most of them are currently 8 gigabytes, but currently we are receiving 11 or 12 gigabyte GPUs. So in the future, this might be a problem, but currently it looks like this is not going to happen, because since its release in 2015, I told you that Ethereum was planning to switch to proof of stake. So they couldn't do it for a very long time. Now it is 7 years, and they couldn't do it. So people were skeptical. But nowadays they are talking about really doing this, because initially they thought that maybe they need like 10 different upgrades to move on to proof of stake. And they are currently almost at the end. I think 1 or 2 upgrades left to move on to proof of stake. So it looks like it may happen this year. So it is proof of work, but since they want to move on to proof of stake, there is a misconception that Ethereum is proof of stake and it doesn't consume much electricity, but it does. So many upgrades led the way to this transition, and it is recently announced that Ethereum may be proof of stake at the end of summer 2022. So the co-developer said that they're planning to do it in August. But if things that do not go as planned, it may be delayed to October, but they're aiming for this year, right? But of course, since they aimed it for a few years ago and couldn't do it, maybe there will be also a delay. We will see. But after this transition, Ethereum ASICs will be useless. So a lot of people don't know this and keep buying ASICs for Ethereum. So what will happen is that either another cryptocurrency will modify their mining algorithm, and they will say that, okay, we now support ETH hash. You can use your ASICs to mine our cryptocurrency, so that they might think that their price will increase due to this modification. Or there can be a hard fork since when Ethereum moves on to proof of stake, probably other people will not, and probably we will call it something like Ethereum Classic 2 or something else. Okay, so but this is now what they're planning. So for years they named this project as Ethereum 2.0, but now that it is going to happen, they removed that name, and now they are calling it Ethereum Merge. So they say that the execution layer is Ethereum 1, and the consensus layer, which is currently ETH hash mining algorithm, will be simply changed with the proof of stake algorithm. So with this merge, you will have the Ethereum Panda at the end of this picture, right? So this is what is going to happen after this merge. So officially, it is now called Ethereum Merge, not Ethereum 2.0. Okay. So Ethereum 2.0 was used to refer to proof of stake consensus layer for Ethereum. Since the upgrade is expected to happen between August or October 2022, the term Ethereum merge is used instead of Ethereum 2.0. This merge is supposed to solve some of Ethereum's biggest issues, like high transaction costs and the network's ability to scale. Under the current proof of work model, Ethereum issues roughly 13,500 Ethereums per day, an annual issuance of about 4% of the total Ethereum supply. So, however, the proof of stake issuance model is determined based on how much ETH is actively being staked on the network. So this 13,000 probably will be halved 3 times after this transition. Okay, so this is why some people talk about is triple halving, and we will see how it will affect the prices at the end. Okay, so in the last slide I will briefly talk about smart contracts, because Ethereum is famous with this. These are software programs that automatically execute the terms of an agreement between two transacting parties without the need for a company or other intermediary to intervene and ensure that the two parties fulfill the terms of their agreement. So it is not specific to Ethereum. You can do it in many different blockchains. You can even do smart contracts in Bitcoin, but in the Bitcoin blockchain, you cannot do it in a single transaction. We will talk about this when we talk about NFT, but you can sell an NFT on the Bitcoin blockchain, but you cannot do it in a single transaction. You have to do it in 2 transactions. One will transfer the NFT, the other one will allow you to, earn your Bitcoins from this transaction. But with these smart contracts in Ethereum, you can do this in an atomically in a single transaction. So the contract executes itself without anyone overseeing it. No one has to enforce this transaction. So smart contracts are often used to execute contracts and agreements efficiently across blockchains such as Ethereum. So this is why a lot of projects use Ethereum instead of Bitcoin blockchain, because they can write smart contracts here, introduce new cryptocurrencies here, and so on.